With our shipping container buried and our pivoting solar array mounted, it's time to set our sights on the end goal. A massive off-grid electrical system that will be able to power all of our dreams. In this episode, we have some special guests help take this project across the finish line.
With our panels mounted, it's time to start on the inside. We're gonna be insulating the inside of this thing and adding some framing so we have a place to mount stuff.
Which one am I grabbing?
Whichever one you can get out.
No.
No. Well, I think we have to unload it all. All right.
Working in this container is very nostalgic for me. We actually built a 40-foot shipping container house 3 years ago, and we lived in that for a year. It was a really fun project. It ended up being a smaller space than we really wanted to live in long term, but it was so much fun to build, and so this kind of reminds me of that, but it's very different because we're not gonna live in this one. I wasn't ready for snow in July.
That's funny. We started this container project by buying an inexpensive, very used container. Our goal for this project is to maximize our value here and really minimize our cost input, and going with the styrofoam rigid insulation was just way cheaper than going with spray foam insulation. So we have a plan for insulating this that I think is going to be a pretty good vapor barrier and should help minimize any condensation issues we have. Can you tell me about your straight edge?
It might be straight. Oh, it's so bright. Ah. Does that mean you fit out the window?
You want to find out?
Nice.
That goes now. One of the most asked questions on our last video was why we buried this container in the first place. So our hopes is that we get some geothermal properties from the earth behind here to help both keep the container warmer in the winter and cooler in the summertime. So we're not going to insulate this wall because we want that heat transfer from the ground into the inside of the container. We're insulating the rest of it to keep the sun out.
Riley said that this is going to fit, but I'm a little bit skeptical. Let's find out.
Cool.
The biggest downfall to shipping containers is the beer can effect that happens if you start trying to do any sort of climate control with them. If they end up a different temperature than the outside temperature, they're going to basically turn into a beer can. It causes moisture to condense on the walls. That can make them rain, that can cause mold, it can cause all sorts of issues. Because we're not planning to live in this and incorporate a ton of moisture from cooking, showering, that kind of stuff, I think we're going to be able to get away with not having to do spray foam. But we still don't want things raining or condensing on all of our really expensive electronics. So we're going to try to do our best to prevent any air from getting behind our insulation and trapped on the metal.
Is it terrifying?
A little bit. I just don't want it to fall on my face, on my hair. The goal is to not get it in my hair. To be honest.
Nice. I watch Courtney use spray foam and it always looks so easy to me, and then if I get a hold of that can, there is just a humongous mess everywhere.
Oh, there we go. Just go.
Now before we go ahead with our roof framing, we're going to stick our ceiling insulation in, and then our roof framing is going to hold it up. So another thing with this design is that the insulation is continuous, meaning that there's no thermal bridging from the outside world to the inside world because our studs are on the inside of the insulation. That's going to get us a lot more thermal performance out of this R6 insulation than if there were gaps in it with a stud every 16 inches like a traditional house. You're making a mess around here.
I feel like I've been here before, familiar with the view. This ain't nothing new. And every time that you walk through the door, I'm hit by the same old tide, blinded by the lights, and I'm going through changes, but it's easier with you. I'm going through changes, and so are you. I live for the moments when you're around me.
We are only doing this small section back here right now because we have to be ready for tomorrow when someone very exciting is coming to help set up our batteries, our inverters, and all of our power system.
We kind of put this project for last minute, but I think we're barely going to make it.
Do not drop that.
Wait, what'd they say? Pour from the top, huh? You ready?
Yeah. They were right.
How much? How much? How much?
I don't know, that much?
I do think that made less of a mess.
Thanks, guys. That was a good tip.
Ooh, that's a nice color.
White.
First coat down. I thought I'd give you a little sneak peek of what's to come. You've already seen the solar panels, but here's the rest. We have 12 48 volt batteries to give us approximately 60 kilowatt hours of energy storage, and two 10,000 watt inverters that are going to combine to get us 220 split phase power. I am beyond excited to get this stuff installed tomorrow. We'll wait for the first coat of paint to dry. I'm going to get our exhaust fan installed. This is actually a temperature and humidity sensing automatic exhaust fan that comes with this flap louver on the outside. It's a pretty cool unit. Check out the link below. First things first is to see if it fits. Probably should have checked this a long time ago. Oh, like a glove. We've got an extension cord running all the way from the solar shed where our Delta Pro is, all the way around up to the solar container. Time to test out the fan. Oh yeah, that's a lot of air. The next step is that we're going to need a way to get the wiring from the solar panels into the inside of this container. I'm going to use this junction box to make us a nice watertight place to do that. Today is finally the day that we're installing our long-term permanent off-grid power system. So Courtney and I have been living off-grid now for a little over 2 years, and between the camper system, our generators that we ran when we were building the building, and then the EcoFlow Delta Pro, we have a lot of experience in some smaller off-grid systems. Today we're installing a massive off-grid system, and I'm so excited. We're so appreciative of Dexter and Current Connected's time for coming up here to get all of this set up correctly with us, and I can't wait to see how it goes. Oh. They're heavy.
Oh. You're gonna hurt yourself, dude.
Each one of these is equivalent to about 1.5 times the capacity in our camper. So we're gonna end up with about 18 times more battery capacity than we've ever had before. And I'm excited because that's gonna allow us to use whatever tools we want up here, including our air compressor, our welder, our plasma table.
After living off-grid for basically 2 years between the camper and then here, we've gotten really good at being frugal with power. And the thought of not having to be frugal with power is a foreign concept by now. So I'm really excited to be able to do things like, well, I already kind of do everything I wanna do. But now I don't have to ask Riley if we need to fire the generator up.
Dexter just called, he made it to the bottom of the hill, but he's in a Tesla. So I'm gonna go get him. Okay guys, it turns out we have not one owner, but both owners of Current Connected here today. So we're here with Dexter and Jarrett, and they're gonna be walking us through every step of this installation, which I'm excited about because I can already tell that I'm a little overwhelmed. Okay, so what's step one?
I think we should at least get the batteries out of the boxes, get the racks assembled, and kind of get a layout, see how things are gonna fit together. And from there, we can kind of just start piecing all this together.
Awesome. Holy smokes. So before Dexter sent these to us, he actually pre-programmed them for our application for using 2 of these inverters in series with the charge controllers and the batteries that we're using. And you can tell because he includes the sheet that says exactly what's on them. And this is a standard service that they provide for all Victron components at no cost. So when you buy Victron from Current Connected, you know you're getting the right stuff for what you're doing.
Those are heavy.
Yeah, no kidding.
Working hard.
You were designing on the fly over here.
I would just like to put on the record that I have built 3 battery racks and Riley has mounted 2 brackets.
We're doing a lot of talking and not a lot of working. I think it's time to get to work.
How would we have put that up?
Pulleys. I'm just starting to really grasp how much battery this is.
One down.
The good news is that I put the racking together properly and the batteries fit. Last box.
We're gonna be charging before the end of the day.
I had no idea that we were gonna be charging today, and now I'm like a whole nother level of excited.
We have made way more progress than I expected, and we're getting really close. I think we have like 4 more cables to make, and we have some solar panels to hook up.
So I'm connecting these panels in series, so essentially the positive from one to the negative of the next.
So each like of our rows will be a string.
Yep.
And then
exactly.
they'll go down into this
Yeah,
box.
there's a junction box. Yep.
That Riley put in. Cool. Dexter just yelled down at us, "Did you know that one of your panels is broken?" And I said, "What?" And Riley got this grin on his face because he knew it was broken because he broke it and he hasn't told me. So maybe it's Dexter's fault for telling me. I probably would have never known. But they think it's still going to work. It's just the back of the panel, since these are bifacial, it's the back piece of glass. It could corrode over time, but the panel should still work right now. So Riley's only half in the doghouse. We had the array set up in winter mode for painting, so it's time to tilt it into summer mode, and that will also make hooking these panels up easier. Oh, there it is! Okay, you guys, we really want to test this system today, but the sun is about to go behind our hill. So I think they're working as quick as they possibly can while also being safe. Right? They're also being safe.
These are disconnect switches for the solar panels that are going to allow us to be able to shut the power off from our solar panels to the DC distribution bus, because without these we'd have to physically unplug the panels to turn them off. And according to Dexter, I'm not allowed to do that under load. We're putting these disconnect switches on the outside so that if something were to go haywire, we don't have to go inside the container to unhook all this. We can just turn the power off right here on the outside.
Panels are already shaded, so there's just a little teeny tiny spark in there.
Sorry, Riley, no boom.
I was promised fireworks.
Look away, because it's like welding. You see that spark?
Whoa!
That's so cool. That's awesome. All right, we have like 10 minutes of sunlight left. We're gonna try to get some power into this system. I'm connecting this one to the positive.
Are you positive?
When Dexter flips the switch out there, it's going to connect the solar panels to the charge controller, and this is going to turn on.
Hopefully.
Hopefully, the sun is going away as we speak.
Oh,
What?
it lit up.
It did?
It lit up for a second. The battery's on.
So now this is the most important part, especially with these massive inverters. I'm using a pre-charge resistor. I have this pack on and this one ready. So as soon as I touch this, it should charge the system up and this pack should turn on, and then I can make this last connection. With inverters this big, it's above the rating of the pre-charge circuit built into the battery. So here goes nothing.
Oh, everything's flashing. Things are doing things.
It's like our sleeping beast.
So now this is all live.
Wait.
Oh, here's why it didn't turn on, because there's the on switch at the bottom.
Guys, we're making power.
All right, now that it's all installed and running, Dexter's gonna run us through a little more about what each one of these pieces is and what it does.
So these are the SOK 48 volt batteries. With the 12 of them we have here, there's about 60 kilowatt hours of storage. So we're going with these lithium batteries over lead acid because they're 100% maintenance free. They're rated for over 4,000 cycles. And then two, with this rack mount design, there's two great benefits to it. One is you can start small. You can start with just one battery and expand it later to fill the rack or add multiple racks, as well as it takes up a ton less space than a lead acid battery. So these are pretty much 100% maintenance free. There's no off-gassing, and the management system inside will even tell you if something's gone wrong. So these batteries are connected up with 4-aught cable. These are also available from us here at Current Connected. We have a special hydraulic press that crimps these so tight. I was showing a sample to Riley and Courtney that it pretty much cold welds the strand of copper for ultimate connectivity.
It's really important to me that these cables be made well, right? Because we're expecting that this is a 10-year maintenance-free system where I never even have to look at it. And so if I had 10 years worth of hot and cold cycles on this cable, it would over time stretch out, loosen up, and could be a major fire damage. Maybe not tomorrow, maybe not next week, maybe 7 years down the line. And I don't want to have to worry about this in 7 years. So we've got the inverters, the batteries, the charge controllers. These are what the solar panels use. But all of this in the middle was the part that I was pretty intimidated by.
So right here we have the Lynx power in. It's not as complicated as it looks. It's essentially just a chunk of copper that's tin plated, and all of our cables connect on there.
Basically a big junction box.
Exactly. From there we come here to the Lynx shunt. This has the main system fuse, so if something catastrophically happens, that's going to blow and protect them. And this also has a 1000 amp shunt down here. So essentially all a shunt is it's a device that measures the current running through the bus bar so we know how full our batteries are. From there, we go to the final component of our power distribution. That's the Lynx distributor. So in here is all of our fuses and final cables to go to the rest of the system. We made a temporary connection here, but I'm gonna get some new cables shipped down to Riley to fix this here.
That was totally my fault. I bought the wrong ends at our local store for crimping onto that cable, and we were so excited to get this thing fired up that we made some cables. So don't do your crimps like that.
From there we have some equal length cables that come up into each inverter, and that's very critical with this Victron equipment. From there the inverter is essentially the device that turns it from 48 volt DC battery power to your 120/240 split phase that then goes to the shop.
One of my primary goals when shopping for all this equipment was to ensure that we would have stuff that could run our air compressor, our plasma table, our welders, and those all have really high startup draw loads.
These are a transformer-based low-frequency unit, which is essentially like a flywheel. So these can do a 2 times surge capability, which means each inverter can do 20,000 watts. So they've got 40,000 watts to play with.
Whoa, what am I gonna do with 40,000 watts?
So to keep this pile of batteries charged, we need some good solar controllers. And we have one of them hooked up temporarily over here, as you can see. But there's 2 of these Victron Smart Solar MPPT RS. These are 100 amp solar controllers, which means we can do about 5,000 watts per controller. So for now, we're only going to be using 1.5 of them, and there's a 4th string ready for more panels to add on later.
What I really love about these charge controllers is they're rated for 450 volts, which let us string more panels together and dramatically decrease the complication of installing them. It also means that we can run a smaller wire size. So you can see here, we're only running 10 gauge wire for our panels. And that means that if our panels were a long ways away, we could run smaller wire that longer distance.
Can I mess something up if I touch?
No.
Okay.
If not, I'll fix it.
Okay, there's a menu. Oh. Something that I really like about this system is not only can it be monitored from this touchscreen, but it can also be monitored from an app on my phone. And it's in a way that I can understand it, because something that I don't want to happen is Riley go out of town and I be worrying about the state of charge on our batteries or if we're getting solar input. And so with the monitoring like this, it really does make it simple so that it's easy for me to understand too.
So at the heart of this system is this Servo GX. This is connected to that screen Courtney was just showing you. And what's really cool about this is they can connect it to the internet, and it can be monitored from anywhere in the world, which means from a support standpoint, if they have a problem, I can remote in and help them out.
I was pretty intimidated by all this. I've seen a lot of photos of Victron systems and they look complicated, but that's because they're modular and very customizable, allowing them to be custom suited to exactly our needs. And after installing this today with these guys, it turns out it's really not that difficult. And so if you've been considering going with Victron or any other solar system, be sure to go check out Current Connecting's YouTube channel, where they have a lot of tutorials and how-tos on how all of this works in a lot more depth than we've gone through today.
Oh, you guys, it has been a long day. I can't believe our system is set up. I can tell you right now that Riley is not going to sleep tonight because he's going to be waiting for the sun to come up tomorrow so he can run out and see our system working. We are tired. We are hungry. We definitely owe these guys dinners, so we're going to treat them to dinner, and we'll see you guys tomorrow to wrap this all up.
All right, it's the morning and I'm trying to be super quiet because Courtney's asleep, but the sun just came up and I think it's about to hit the panels for the first time. sun is at a very steep angle right now. Ooh, all right, we're already making 600 watts total charge. Dexter and I spent the next day getting all the details finished up on this install so that we could get it to a point where we could power our house with it because we were way too excited to wait any longer. The main thing that we had to get done so that we could start using the power out of this system was to get this main breaker panel installed. This is going to be the main breaker panel to feed our entire property, and from here we'll branch out into sub panels anywhere else where we might need power. While we were at it, we wired in a couple of 110 outlets and a 220 outlet, so now we can start using our welder on 220 power, which as you'll see soon, I've already had to do. So for 2 weeks now, we've been powering our house full time with this system, and it has been absolutely awesome. We haven't had to think about how we're using power. We've been using the dishwasher, we've been running an air conditioner, basically just doing anything we could possibly want to do. And we haven't even seen the batteries dip below 95% yet, even overnight.
That's where this video is going to end, but we are so excited to put this system to the test and create more content for you guys, including a long-term review and a video about how much this all cost.
If you've been interested in going solar, whether it be on-grid or off-grid, head to the links below to find out more about all of the equipment that we installed here.
And thank you so much to Current Connected for working with us on this system. We are so appreciative, and I feel like our life just changed.
Let's get back to using power.
Are you eating while laying down?
She's never done that before.
What a goofball.